Thank you very much. I'll never put again so much in my CV, so that's I apologize. What you can take from it that I have mostly a traditional background and not yet. I feel like the small young guy in the blockchain world. I'm starting to read stuff since 2016, but please bear with me and thanks for having me here anyway. So I want to talk about oracles and parametric insurance. This is something that you might have had in the past. It's usually a very frustrating experience. It can have consequences that you have to find a room, have additional travel, whatever. It costs money, and you're really in a bad situation and a bad mood. And insurance is here to help you in a sense that if you don't like this, you can buy flight delay protection. This is what I bought for my flight on Monday. So you have to buy this 2 weeks ahead of your actual flight. And it's showing my flight from Zurich to Berlin on Monday. I pay 15 DAIs, and if the flight is delayed more than 45 minutes, I get back 750 DAIs, which is really, really nice. So I can have a good meal, I can have a good taxi, whatever. It improves my mood. So if you look what actually happens, as a traveler, I should be happy because the delay, it was really on time. 0 minutes delay. On the other side, I wasn't getting those 750 DAIs, which would have also been nice. So this is the introductory example into insurance on blockchain. So it's not only insurance blockchain, it's mostly what we focus on to build showcase product, is parametric insurance. And so I talk a little bit about parametric insurance and what is the role of oracles in that. So basically, I won't explain insurance. So I explain only the difference to classical insurance from parametric. Basically, the main difference is that loss events are defined as a form of triggers on an index value. So in the traditional insurance, if you have a house or if you have a car and you have a loss event, like you smash your car, then you need to go to the garage, they need to assess the damage, and you need to provide those numbers to the insurance, and maybe they agree to pay for it. So there's a lot of back and forth, and somebody's really looking at your thing, whereas in the parametric insurance, you agree on an index, and you agree that you don't look at the actual thing, but you only look at the index. So this has the result that for building products and for pricing the product, you again look only at the index and statistics on that index, which then makes claims and payout handling extremely simple, and which leads to the holy grail or the wet dream of the traditional insurance product, that if you can automate everything, then you have a huge amount of costs that you can save. So parametric insurance has all those combined, so you can go to 100% automatic processing, and you almost have nothing with manual intervention. So that is basically a business that extremely well to scale. Preconditions for this is that you have a lot of data and you have very high quality data. You need the data in 2 places. First, you need the data to build the products and to do statistics. Basically, it means that you need to have access to data years in the past for high quality data. When you then switch, once the product is defined and your stuff is sold, you switch to monitoring the policies or the contracts. When you do monitoring of contracts, you're no longer interested in historical data, but you need accurate near real-time data, or data that is as close to time as your insurance use case, such as this, is useful. Now, oracles, I don't really think that this needs any introduction, especially not from my part. The role is that what we do is these hybrid smart contracts or contracts with real-world data, and then there's simply no way around oracles. You have to transport the data from the real world to the smart contract. Usually not for building the products, but at least for pricing. And maybe you can even skip pricing if you have fixed pricing models, but at least for monitoring the policy, you need this near real-time data or something like that. So it's just, if you do this parametric insurance game, there's no way around oracles. I want to talk a little bit that sideline that we also do, or one of the things that we've been recently doing quite a lot, which is basically impact insurance or micro insurance. And here I'm talking about crop insurance later. First, I want to introduce some goals. So basically, one of the goals of micro impact insurance is to contribute to help people go out of poverty trap for low-income households and people. And it can have a huge impact because it adds financial stability to these guys of people, and there are many of those. So if you're on $4 or less income per day and person, then you're between 2 and 3 billion people that are actually living in this situation. And what it concretely means that if you're a farmer and you have 2 seasons of drought or 3 seasons of drought and you have no financial stability, it basically means that you're no longer a farmer. Your only option is go to a large city and try to get day jobs. And then you lose a lot. You lose your whole background, you lose social context, and basically everything. And if you're used to insurances, then this cannot happen because the insurance is covering these high risk and high loss events, whereas for a larger amount of the population, this is just not available. So the challenges in building and deploying and distributing something like that, your customers, there's a huge amount of lacking of education and understanding of trust. So they do not know what an insurance is. So you try to start to explain, well, an insurance, it covers, if you have a drought, then you will get a lot of money back, and then they think, yeah, but how can you pay this? And that, yeah, you need to pay insurance, you need to pay the insurance premium, and then usually they believe the part where they're supposed to pay the premium. And that's what I've heard in the past many times. They do not believe that they get any money back in the future, because this is like, yeah, it's a usual game. I give you money now, and then my money is gone, I have nothing in return. So there's a huge amount of lacking of trust, especially into organizations that have been scammed too many times in the past. Also, many of these guys are excluded from financial infrastructure, which is slowly changing now, especially in Africa, where you have this mobile money. Basically, all the farmers have, if not mobile phones, they have feature phones, which are good enough for mobile money. So that starts to create a form of financial inclusion where there was no financial inclusion before. So this is a good part. And again, something less good is the traditional insurance. Basically, they could cover for losses of droughts. But what they cannot do is target this type of people, because just onboarding a guy costs $20 US. And if the premium amount is $4, there's just simply no business. So the whole space here is not seen as a business for the traditional insurance companies. So the problem statements, if you take this crop model, is on the left-hand side, you have this farmer with his feature phone and no money and the risk of a drought. And on the right side, you have this investor with a huge amount of capital, let's say risk capital. And the idea is how do we bring these two guys together? And the fundamental good thing about programmable money is that you can actually do something like this with a platform. And it can start here with the feature phone where you can apply for a policy. This then creates a policy on-chain. And if you have many of these policies on-chain, then you can pool those things, and then you pool all the premium amounts in this policy thing. And then it might start to get attractive for investors. Maybe not for a single country, but if you can do this for many countries, you can hedge your risk by covering many countries at the same time. And a part of the premium amount is, of course, then the return the investor is asking for his capital that is pooling it. If the investor is pooling a lot of capital there, and you have really the exceptional case of in many countries, in many areas around the world, you have droughts at the same time. Yeah, this is the risk to the investor. He's going to lose a lot of the capital. But it also means that the insurance is not bankrupt after such a game. So they actually have capacity for those policies they can sell to farmers. Once the thing is actually alive, the farmer puts the seed into the ground, again via feature phone, you can get the information which phone number has planted what, in which location and what date. And this is your trigger where you can then use satellite or any form of weather data to actually track what is happening to that particular place. And with the plant model, you can then basically calculate how much the loss would have been, or how the loss is supposed to be in that location for that farmer. And based on that index, you can then do, again, payouts. If you can do payouts, you can use the same channel where the phone money is coming. You can send the money back to the phone using mobile money. This is the situation what we can do now. Of course, the vision is not to do this with mobile money, but with crypto money. Then it would be really seamless from the policy to the risk capital at back. But we are basically in between the state where we want to be and the part where what we actually can implement. So from the farmer perspective, it might look like this. You have a bag of seeds, and in this bag of seeds is a scratch card with a code, and the farmer can basically activate his policy by entering this code on the scratch card into his feature phone. and back and forth with some numbers and something like SMS, which is called USSD. You basically can get information directly from the phone from the farmer what has been done. So from the farmer to the actual policy on which we can have on blockchain, you have a direct link. You can create direct links. So basically, you can exclude all possible intermediaries or possibilities for fraud from that angle, which can be very valuable. This is a rough overview of the system architecture. Can I maybe, is there something like this? Okay. So the farmer here, via USSD, can activate his policies. Here we have the personally identifying information in a traditional backend system, and whatever is not personally identifying information, basically what is needed to create a policy on the blockchain, is written to the blockchain. On top of our framework, we can build any products, and if we activate something like a product, we can then ask via Oracle for prices, or during monitoring, we can then move to the next step. So if for monitoring, we want to know a price, this product cell will give me the loss for the season. This one is going to fetch data via the Oracle from some weather satellite, a data provider. Usually, this is a large amount of data you get from many days, many weather points, many irrigation or rainfall things. You need to process that, and only the final result, which is really related to the actual loss you want them to pay out, is actually written back to the Oracle on-chain. And from that, you can do payouts. This is what our partner organization in Kenya sees from the UI part. They have overviews of our group policies. Group policies are basically collections of individual policies that are in the same place for the same crop for the same plotting date. So you can accumulate, you have only to calculate this once for whatever has been sold for this especially form of aggregation. And then you can put that on a map. And on the map, you can then see these are 10 by 10 kilometer pixels for group policies or policies. So basically, if it's red, then there's dozens or hundreds of policies sold. If it's blue, it means that the actuarial department actually has priced the data. They could have sold something in that area, but actually they didn't manage to sell anything. This is just a kind of management insight that you can have over those sold policies. This is from long rain season last year. So this is basically the crop example. I have 10 minutes left. We should be fine. So I want to talk a little bit about the insurance framework, basically the framework we built at Etherisc, on top of which this flight delay protection and these crop products are built. It basically is an end-to-end platform from the policyholder to the risk capital providers. Policyholders, products, and oracles are already implemented. Risk capital providers, or basically risk pools, is the thing that we are currently implementing, and we're in the middle of close to final of conceptual parts. What we want to build is basically an ecosystem of product owners. These are the guys that build the actual products. So we're not really interested in building the products ourselves. We just do this as showcases for now. And the oracle providers, basically whoever has data to sell, would or could be interested in having oracles on that platform. And the risk capital providers, of course, they would invest then in risk pools that cover the policies of certain domains. The thing is product agnostic, so it's not restricted to parametric insurance. For us, it's just much simpler to do parametric insurance than anything that has manual processing. It's EVM-based, so you can deploy the framework on any chain that has EVM support, and it's open source. So there are no closed source parts about the whole thing. About the stakeholders mentioned before, we have this guy on the left, basically the customer, the insured person, and we have the investor. Inside of the ecosystem, we also have the product owners that build these products. We have the oracle providers that have some sort of data that is valuable to create products, single products or multiple products. That can be weather or flight delay or whatever comes to mind for the specific product. And then the risk pool keepers. These provide basically the shells for risk pools where you can invest money and define in what type of risks you're interested and keep track of that. And below, there's the instance operator. Basically, these are business processes, services, and access to data. And these things are then governing about which products can be on the platform, which oracles can be on the platform, and how does it work with with suspending stuff if things should go wrong and all these decisions. And ideally, this is not a single person, of course, but it's basically the goal is that here is a DAO that is controlling, that's taking the function of this instance operator. And the stakeholders of the DAO could be all the stakeholders here, from the insured to the investor. Basically, whoever is taking some assets or is making use of the platform is supposed to have a right to also contribute to the decisions of the DAO on how to operate the platform. There might be many platforms in parallel, depending on the needs of the product. There might be platforms that want to implement full KYC, and there might be platforms they actually do not care about KYC. The idea is that we as a platform provider are unopinionated in that. So we actually do not care. We want to provide the technology and the platform, and then depending on the needs of mostly of the product owners or the market, we then look that such platforms start to come into reality. A little bit more about oracles. They are first-class citizens. So as explained before, there's just no real-world use cases or no real-world use insurance without real-world data. And there's an oracle lifecycle, so you just cannot put the oracle there. You have to apply to the instance that you want to be an oracle provider, and then the operator approves the oracle, and only then you can actually start to use this together with products to sell policies. By linking this oracle to product or to products, and creating new policies and monitoring of those is also done via oracle requests, and oracle providers are, of course, funded by providing data to the actual usage of monitoring or applying. So if you dive deeper into Oracle and goals and reality, this is kind of the thing what you would like to have, decentralized Oracle networks, basically as trusted data. So we want to know that the data that we use for pricing and for monitoring is actually real data and the true data that is needed for that use case. As seen before, we can usually not directly take the data from the data provider in its natural form, because that would be too much to store on-chain, and there's need to be aggregation and processing on it. So we need some sort of trusted computation before we actually push the events to the chain. And decentralization, so we want to remove single points of failure on how this data gets into on-chain. This is the standard chain link picture, so we have a trusted data in a sense, or basically here you decide to trust Binance, and on the other one you have data coming directly from on-chain, which you can assume that is trusted. Then you have some decentralization price on the price aggregation level, and then you have also decentralization on pushing those aggregated stuff on-chain, and on-chain you can do, again, a sequence of aggregations. Again, I'm not here to explain. Most of you, or many of you, know actually much more about this than I do now. So, but this was the good thing, and this is the thing that very often in our prototypes, on your showcase product, we actually have, and this is the thing what we can expect for the near future that is close to what most of these guys will be building. It starts that you have a single source of data. And it's not even open data, but it can be proprietary data. So basically, a satellite data provider is giving you an API, and you just get the data, and they claim that this is good data without your possibility to really check that in any form. Then you have a use case specific server. This is basically processing the data that comes from your original source into a way that creates actionable event data for your insurance use case. And so far we have single centralized Oracle nodes, and maybe two to cover if one node is down, but this is also not decentralized, so it's a single point of failure. And there's a smart contract acting on the event data that is provided by the operator. So we should and can, of course, improve. We could push the data that we get. If the data owner agrees, we could push that to IPFS so that it can be actually validated by an external entity on what was the actual input data. We can push all the processing and source code on IPFS and on GitHub, so that basically you can reproduce what has then been pushed on chain on your own machine if you want, which again adds transparency. You can add a little resilience by using this failover stuff of Chainlink or whatever Oracle provider you use, and you can, of course, add failover to Chainlink nodes. Further potential is run multiple oracles on chain and aggregation, and basically get proven original or initial raw data. For the African case, we were using this ARC2 data, which is public from the NOAA, and it's kind of weird. This is data used in science and in many products, and it's public. But if you actually get the data, it's from a public FTP node without any authentication. And if you try to actually talk to the guys on, sometimes data is there and sometimes it's not there. And if you try to fetch one of those guys in order to see when do they push the data and how finalized is the data, and are they sure that they're not going to change the data in the past, and how they manage, I have probably tried 2 or 3 months to contact. I was talking via many people on many emails. I was absolutely not capable to actually talk to a real person about what they really do. And this is the data that most aggregation services use, or one of the data points they use. So we're really, really far away of anything that is proven or trusted. It's just everybody uses this and they feel comfortable, but from the perspective of blockchain or what you expect from pricing data on DeFi space, it's a huge gap. And of course, verifiable calculations, trusted compute. Takeaways, oracles for parametric insurance. Parametric insurance is a great case for real-world use case for oracles. And first products are actually live, and we can try them, we implemented them, and we're in the process of doing much more in that area. And you just need to realize that trusted data and trusted compute and decentralization is still major challenges. So we're fine on the smart contract side. This seems to be manageable. On the other side, insurance is a data business. On the raw data, until how that data goes into the system, this is still a big open challenge. I feel we're still very, very far away from what we have now on DeFi space, and most of the talks here talking about DeFi space were saying that there's so much lacking in DeFi space, and now I'm here and saying, well, compared to you guys in DeFi space, decentralized insurance is still miles away from where you already are on decentralized finance. Yeah, so let's build products. The stuff is open source and a good starting point, and I'm looking forward to your questions and feedbacks. Thanks.